Second chapter, first topic, electric potential or electrostatic potential or simply potential. Okay, if this is a charge, to find influence of the charge at this point, we can use electric field, and electric field is force per unit charge. Influence of the charge at this point can be understood using this physical quantity called electric field. It is a vector quantity. Now in this chapter, let us try to understand the influence of a charge at some point through a scalar quantity. That scalar quantity is called electrostatic potential. Okay. Let me consider a positive charge fixed. This is another positive charge. To bring this charge closer to this fixed charge, we have to do work. So what is the work done to bring this charge from this point to this point? So work done to move this charge from this point to this point like this is 2 joule. Say 2 joule. Similarly, work done to move this charge closer to the fixed charge. Much closer to the fixed charge means work done should be more. Say 4.5 joule. Why? Work done to move from this point to this point is less and from this point to this point is more, means as the charge approaches the fixed charge, repulsion between the charges will increase because force is inversely proportional to square of the distance. If distance is less, force of repulsion is more. We have to do more work to bring this charge closer to the first charge or the fixed charge, isn't it? Now, this electrostatic potential is defined based on this work done. Potential at a point means electrostatic potential at a point is the work done in moving unit positive charge by an external force from infinity to that point. Therefore, potential, let us denote it by capital V, equal to work done by charge, W by Q naught. Since it is work by charge, SI unit is, numerator is joule, denominator is charge, joule per coulomb or volt. This is special name. Symbol is capital V. Okay. As far as possible, try to avoid notations like this, joule per coulomb. Okay. Since it is ratio of work scalar to charge another scalar, this potential is a scalar quantity. And dimensional formula of this, it is work by charge. Work is mL2 T minus 2 by charge is coulomb. Coulomb should be written as ampere time because current is one among the 7 fundamental physical quantities. Current is charge by time. Charge equal to current into time. Current is ampere. Time is T. So whenever you come across coulomb, please write AT. And if you simplify this, M L2 T minus 2, if this T goes to numerator, it becomes T minus 3, A minus 1. This is the dimensional formula. From this small topic, questions could be like this. Define electric potential or electrostatic potential. You know this statement. Mention SI unit of electric potential. You can write in terms of Newton, Joule or Volt. Is electric potential a scalar or a vector? It is a scalar quantity. If reason is asked, you can say since electric potential is the ratio of work and charge, both are scalar quantities, therefore electric potential is also a scalar quantity. Okay. Now, second topic, expression for potential due to a point charge. This is that expression. Derivation of this expression, V equal to 1 by 4 pi epsilon naught Q by R. Okay. This can be asked for 5 mark, 4 mark or 3 mark. This is some charge. Because of this charge, what is the electrostatic potential at some point P? Okay. That is the aim. Consider a point charge Q in air or vacuum. What is the reason for taking air or vacuum? We can eliminate epsilon r, means epsilon r can be taken as 1. Okay. Let P be a point at a distance r from Q. Where electric potential should be found. This is the charge, given charge Q. This is point P. P is at a distance r from the charge. We have to find electric potential at P. Let us keep another charge Q0 at P dash. This point is P dash. Let us keep Q0. This is imaginary line. This Q0 be at a distance x from the charge, fixed charge. This distance is x. This Q0 experiences force of repulsion due to this charge, and the force of repulsion on Q0 is in this direction, repulsive force like this, and this is the direction of electrostatic force of repulsion, F. This Q0 is moved through distance dx towards the charge. This is the displacement of Q0. This displacement is dx. If this distance is x, let this be small displacement dx. Angle between force and displacement is 180 degree. Theta equal to 180 degree. Okay. Let me explain. Q is a point charge. P is a point where we have to find electric potential. For that, consider Q0 at P dash. Distance of Q0 from Q is fixed charges x. Because of like charges, there is repulsion. Let this be the force of repulsion on Q0. This Q0 is moved towards Q through displacement dx. So angle between force and displacement is 180 degree. First step, force on Q0. Force on Q0 is F equal to constant. This constant is 1 by 4 pi epsilon naught, this constant, into product of the charges q naught by distance between these two charges is x. So inversely proportional to square of the distance. This is the expression for force. Next, work done for small displacement dx is, let that be small work done, equal to force dot displacement. It is dot product of force and displacement. So it is magnitude of force, magnitude of displacement into cos 180. Cos 180 is minus 1 equal to minus x into dx. Now work done to move the charge q naught from infinity to this point. Total work done is, total work done W equal to, it is integration of dW equal to integration of this minus f into dx minus f into dx. Limits are from infinity to this point P at a distance r. Therefore infinity to distance r. Minus f is constant q naught by x square, integration of constant q naught by x square into dx equal to minus constant k q naught integration. This x square goes to numerator, means it becomes x to the power of minus 2 into dx. Limits are from infinity to r. Of course here also infinity to r. We are using this formula. Integration of x to the power of n into dx is x to the power of n plus 1 by n plus 1. Increase the exponent by 1, write the same exponent in the denominator. Okay. If limits are given from a to b, then we have to write like this. Limits are from a to b. For example, integration of x to the power of 4 means x to the power of 4 plus 1 by 4 plus 1. Limits are from a to b. Write from a to b. Simplify. Denominator is 5. Numerator is x to the power of 5. Integration of x to the power of 8 dx. X to the power of 8 plus 1 is 9 by 9. Limits are from a to b. Integration of x to the power of minus 3 means, again as usual, x to the power of minus 3 plus 1 is minus 2 divided by minus 3 plus 1, same exponent. Minus 3 plus 1 is minus 2. Limits are from a to b. This is how we use this formula. I'll be using that formula now. Minus constant q naught x to the power of minus 2 plus 1. X to the power of minus 2 plus 1 is minus 1 by same exponent in the denominator, minus 1. Limits are from infinity to r equal to minus k q naught. This minus becomes plus. X to the power of minus 1 is 1 by x. Limits are from infinity to r equal to k q naught, constant q naught, give upper limit 1 by r minus, give lower limit, 1 by infinity. This is work done. Equal to constant q naught by r. 1 by infinity is 0, very close to 0. 1 by very large number is very close to 0. That is the meaning of 1 by infinity 0. By definition, potential is work by charge. Implies here is work, here is work by charge, equal to kq by r. Therefore, V equal to constant is 1 by 4 pi epsilon naught into q by r, charge by distance, q by r. So this is the required equation. First note, if q is greater than 0, means for a positive charge, potential is positive. And what is the positive potential means? Work is done by the external force. If this is the fixed charge, if this is another charge, positive charge, work is done to bring this charge from infinity to this point. So that work is done by the external force. So positive potential means work is done by the external force. Second case, if q is less than 0, means negative charge. For a negative charge, potential is negative. This is the fixed charge. I want potential at this point. This is always positive. Work done to bring this charge from infinity to this point. We don't have to do any work because of this negative charge. Because of this negative charge, this charge is pulled. Therefore, work is done by the electrostatic force. In the first case, work is done by the external force. In the second case, work is done by the electrostatic force. We are not doing any work. Remember, if q is less than 0, work is done by the electrostatic force. Third note, a graph of electric field versus electric potential. This is distance, y-axis, electric field and electric potential. Electric field is inversely proportional to square of the distance. Electric potential is proportional to 1 by r. Therefore, electric field should be steeper. If this is electric field, then this is electric potential. This electric potential V is proportional to 1 by r, whereas this is electric field. Electric field is proportional to 1 by r square. If you carefully observe, at this point these two curves will meet. So this is the point where magnitude of electric field is equal to magnitude of electric potential. Magnitude and distance are equal to 1 meter, because 1 by 1 is same as 1 by 1 square. These are the probable questions. Mention an expression for electric potential due to a point charge. Just write the expression. This is for 1 mark. How does potential change with respect to distance? It is 1 by r. This is also for 1 mark. What is the meaning of negative potential at a point? Negative potential means work is done by the electrostatic force. 1 mark. Draw a graph of potential and electric field versus distance due to a point charge. Just now we 1 mark. What is the electric potential at infinity due to point charge? So electric potential at infinity is 0 because distance is infinity. Potential is inversely proportional to R. I am not writing. You have to write the answer. Okay. Answer should be V is proportional to 1 by R. If R is infinity, then V is 0. So potential is 0. This is also for 1 mark. Derive an expression for electric potential at a point due to a point charge. You have to derive. This can be asked for 3, 4 or 5 marks. Okay. That depends on the question paper setter. And according to the marks, they'll design the scheme of evaluation. Students, like and subscribe the channel. We are going to discuss all chapters of 12th and 11th NCERT physics. In Karnataka, it is 2nd and 1st PUC physics. For notification, press bell button. Share the link of channel in all social media platforms like WhatsApp, Facebook and Instagram. Let's meet in the next topic.